io parto. Okay. Hello, everybody, and thank you very much for joining tonight, the meetup of Data Science Milan. Today, we're gonna cover a topic of MLOps. The title is You Don't Need a Bigger Boat, Serverless MLOps for Reasonable Companies by Jacopo Tagliabue. Let me tell you a little bit about us. We are an independent group that was founded in 2016. We are a technical community. Right now, we are more than 1.7 thousand members on Meetup, but we are approximately twice as much if we consider all of the different channels where we advertise our events, and we meet typically once a month right now online, and we hope we can go back to physical meetup pretty soon. We are part of a larger association, which is the Italian Association for Machine Learning. And the staff is made of the people that are in this slide. We have different roles, and together we are the volunteers who arrange all of the events, the pre-work and the post-work, and during the event, everything necessary for delivering these meetups every month for you. We are looking for other volunteers who would like to join the staff. And in particular, we're looking for like any role, but if you specifically would like to give some help with the social media management or with the contents on our website, this is something that we really need at the moment. You can check out our website, www.datasciencemilan.org. And in here, you can find everything about what we organize, the previous events. You can find all the contacts and all the different resources related to Data Science Milan, such as the recordings of the previous talks that are on our YouTube channel, and the link to the SlideShare account where you can find also you can download the slides. We also have a blog on Medium where you can find summary articles by written by Claudio. Typically after a few days after the event, you will find the summary article published on our blog. And you can also join the monthly digest. It is a newsletter we send once a month with all the updates from the community and from the AI industry, the data science and machine learning industry, both in Milan or Italy, but in general, everything that is going on, even worldwide. The major communication channel to stay in touch with the other members is Slack. So on the website, if you scroll down at the bottom, you will find you'll find the text box where you can type your email address. You will receive an invitation, or there's also a link you can follow and you can join on Slack. And this is the place where you can discuss about any data science topic, as well as meet with the other attendees of the events. If you would like to propose a talk, you can send us an email at datasciencemilan@gmail.com. And now let me give you some quick updates from the community, things that are going on. This is one of our historical loyal member, Marcos Antoni, was probably one of the first to join the community years ago, and is still one of our top followers. And he is running this podcast about Python. It is in Italian. So for the Italian audience, this is something we strongly recommend. And then there's a company in our network where a colleague of ours work and is looking for a senior data scientist and machine learning scientist roles. So if you're interested in digital medicine, this is a very great opportunity for you. Another company of our community network is Qubit, which is looking for data engineer with cloud infrastructure experience. It is based in Milan, but it is open to remote opportunities. And then there's also Brainly, which is the company where I work for, which is looking for a bunch of roles, starting from machine learning architect, team leads, machine learning engineers specialized on NLP and MLOps engineers. There are quite a few roles, and the company doesn't have an office yet in Italy. It is based in Krakow and in Barcelona and in the United States. But you can, if you're willing to relocate or you're already based in either Poland or Spain, you can take advantage of that. Also working remotely from any place. You can even travel around as long as you are officially resident in one of those two countries. All right, so if you'd like us to promote something at the next event, please send us your correspondence. And let's move to the topic of today. So the agenda is we're gonna have Jacopo giving the talk about MLOps. But before we start, please, we need to ask you a favor. Everything we do is essentially driven by the passion we have for spreading the knowledge of data science and machine learning. So we need your help in exchange. Please help us spreading the word. Those are all of the major social media accounts. You can find us on all of the major platforms. So please write some posts, tag us, post something, help us, spreading the word. Thank you very much and enjoy the rest of the event. Now I'm gonna ask our speaker of today, Jacopo, to please introduce yourself.
Ciao guys, can you hear me and see me fine? All good, Gianmario? Okay. Let me start sharing my presentation. So because the boring part where I introduce myself is also in there. So thanks so much guys for joining. If I don't hear people shouting, I assume you see my presentation. So thanks so much for joining today. I'm sure you probably could have done better things in your summer in Milan or wherever you are in fancy Europe. For me, it's like midday, so I still have a long way before the end of the day. So thanks so much for spending a bit of time with me. Please, I can see your questions, but I know we have like a system set up in such a way that somebody's going to read them to me. Please feel free to ask anything you find relevant or mildly relevant. This is more hopefully more a conversation with this exciting community more than a talk as in a university lecture. So thanks so much for inviting us. I mean me, but me also representing my team and my company. So this is what we're going to talk about today. A bit of introduction. We're going to define what we call machine learning at a reasonable scale. And then we're gonna work out with some data set what we actually mean in practice. So instead of having empty words or slides, we're actually gonna see some tools. And then we conclude with our latest project, which is called model cards, and we're gonna talk about that. So pleased to meet you. I'm Jacopo. I've been here I think 2 times already. So I'm like a recurring guest of this Netflix series. So I used to be so some of you may have seen me in previous episodes. So very quickly, for those of you who don't have Google, I used to be the co-founder and CTO of a startup in San Francisco, which was called Tooso. These are my 2 co-founders. Tooso was a startup doing NLP and information retrieval for retail. Happened after 2.5 years. Tooso was acquired by Coveo, which is a North American unicorn. For those of you who don't know us, we are a growing startup in the North American ecosystem with offices in Montreal, Quebec City, San Francisco, and New York. We raised more than $300 million in capital in the last couple of years. And we do a bunch of stuff across different line of businesses. Again, sorry for the marketing slides. The company is actually pretty cool, and we're always hiring. I know Gianmario told me to mention this. So if you go on Coveo.com, there's always opportunities for people that want to join this growing company. especially if you are willing to relocate to cold Canada, which is slightly less exciting than Spain that was mentioned just 5 minutes ago. But that's what I can offer. In particular, my team. So what we do in the AI at Coveo, we are member of the not just the product community. We're gonna talk today. Today's talk is gonna be very practical, but we also have this nature of also being somehow contributing to the overall scientific endeavor of AI. And we have a roadmap comprising topics in artificial intelligence, information retrieval, natural language processing, and we published last year in basically all the top venues. So if you were at NAACL like 2 weeks ago, we were there. If you're gonna be to ACL or SIGIR in 2 weeks, we're gonna be there as well. We also recently we had our 15 minutes of celebrity when we won the best industry paper at NAACL. With a collaboration with also Bocconi University. So for those of you that live in Milan, the university. So Federico from Bocconi and Binching, which is from Coveo. So we have this roadmap in MLP. And if you're interested in more theoretical problems, you're super welcome to reach out to me, and we're happy to talk about our papers. Finally, we are the organizer of this year SIGIR Ecom Data Challenge, which just ended. We saw the participation of 20 teams, including some of the best companies on the planet. Most interesting thing is not the data challenge per se, but is the fact that in order to organize the data challenge, we release what's probably is the biggest e-commerce data set ever, and we release it for free and completely open for the community to do the research. So if you're really trying to develop, I don't know, recommender system or prediction system or shopping system, and you need a data set that's very fine-grained and well curated and comes from the real world, please go and use ours. We're super happy to try and help the community build more realistic benchmark that is not the stupid movie lens data set that everybody else uses, but it's completely irrelevant in the real world. So please go check it out, download it. It's all open, it's all free. So marketing, really, small marketing, personal marketing and company marketing done. I hope it's a bit, clear which type of companies we are and which type of problem we try and solve. And today we're going to talk about the practical aspect of all of this. I'm not going to talk about, some fancy NLP models or some, theoretical idea on, from cognitive sciences, but we're going to talk about how you actually build a company that with very, just very small teams in which very small teams can accomplish great things. What we're going to discuss here is what I call the reasonable scale. So the reasonable scale, it's hard to define, right? But the reasonable scale, we mean reasonable in terms of employees, let's say companies which have dozens to hundreds of engineers, not thousands. A reasonable scale also tends to correlate with dimension of the data that you have. We mean that reasonable scale tends to cover the terabyte scale. So not petabyte, not zettabyte, but also not like a few gigabytes of data. Reasonable scale tends to correlate with the funding or the type of valuation that your company is, right? A reasonable scale company is a company that's probably is worth anything between $10 million to, let's say, $1 billion, $1.5 billion, $2 billion, something like that. Which as you can probably imagine, reasonable scale is is by definition the scale of most companies, right? So this talk is not geared towards people that work at Google. That's not a reasonable scale, okay? Or people that work in companies that are so small data-wise or in this dimension that I just explained, they don't really have challenges in how to scale up their machine learning operation. But chances are, if you're listening to this talk right now, you work for a reasonable company. I do work for a reasonable company. I mean, my company is kind of on the verge of the reasonable for some of the metrics that I just described, but it's still like a very reasonable company. And hopefully what you're gonna get out of this at the end of this is that there's never been a better moment to work in a reasonable company and do incredible machine learning stuff than today. So let's go back a bit to what happened to ML in as a discipline, as an engineering discipline, not as a theoretical one. This is false. It's not what really happened, but it's gonna kind of help us set the stage for what's there. So was the first phase when only the Google of these words could do really fancy stuff. And then at some point, some other people realize they can also do some fancy stuff. But then the problem is that this fancy stuff typically sits in notebooks, or they work on your computer, but they never work on somebody else's computer. It's very hard to make them work at scale. They don't really work, and so on and so forth. And then we have a new phase, especially for my discipline, which tends to be NLP or computer vision a couple of years ago, when some large corporation pre-train models and you kind of fine-tune them. And some of us actually figure out how to go from notebooks to an endpoint. If you didn't, this talk is probably too advanced for you. And today we have the problem right now with, we deploy the model, but everything else, it's kind of broken, right? There's a famous picture from a Google work on the right, which kind of highlights where is your model code compared to the ecosystem around it, right? So right now, the field is mature enough for most people at reasonable companies to build a model out of some training data that you have, and even ship it to production somehow. But then all sorts of bad things happen, as the training code is too coupled with models. It's very hard to scale. It's very hard to monitoring stuff, and all sorts of other problems. So the general trend that we're seeing nowadays is that the modeling part is the one that is least and least important. It's less important for several reasons. First, because we figured it out before. And second, because most of the model and most of the things you can do are actually being commoditized by large pre-trained model you can download, and they're gonna mostly be 95% of the job. So models are a commodity, but data pipelines are the advantage. Like the advantage of you as an ML company, as in a company where ML is an important component. I mean, for Coveo, ML is the only thing. Like we just do API powered by ML, but there are, that doesn't need to be the case. Let's say you are Zalando, so you're on e-commerce, okay? So ML is not your business, as in it's not the only thing you do, but it's still a very important part of what you do. So what happens is data pipeline tends to be the competitive advantage. By data pipelines, I literally mean everything that goes from ingesting the data to actually training the model and serving. The model itself, it's way less important than it used to be. So yes, the moment where we're getting paid hundreds of thousands of dollars a year just to do import keras, that days are kind of over. Or at least, they're over in an evolved ecosystem. Then, of course, this thing takes time to propagate around the world. But clearly, there's a change coming, right? What was cool in data science in 2015 is now basically nowhere to be found. So, I still have problem with Chrome at my age. So the second trend that we want to highlight is that, well, outside of very few companies, which are outside the reasonable scale that we define, the vast majority of your data and modeling needs can be met with off-the-shelf tools. So your job as a practitioner in machine learning, if you don't have any, let's say, research and development concern, as in you're not trying to think too much ahead, or you're not trying to solve a fundamental problem, or you don't work for one of the few companies where small differences in models make big differences, then the vast majority of your job is actually how to fit together these pieces in a pipeline that works reliably at scale, and they kind of like produce what people expect you to produce on the business side. There's some differences in company that are very advanced, but again, they tend to be not on the reasonable size, because let's say you're building a recommender system for Amazon, and now you're getting an improvement in your accuracy by 0.1%. That probably translates, in $10 billion at the end of the year. So there's value in marginal improvements when gains are big enough. But most people have not Amazon problems. And so the marginal gain on a normal e-commerce, OVS, Italian e-commerce, random Italian e-commerce, the marginal improvement of recommender system on OVS is not GDP of Quebec. Like it's some small number, okay? So the value is not so much in that improvement, but is all the cost saving and or the scale you can achieve by building a better data pipeline. I hope that's clear for everybody. So it's a fantastic moment to be in this field, mostly because you don't have to do much. And today's talk is kind of a monument to this idea that your job as a machine learning person has been shrunk in the last 5 years from doing a lot of complex stuff that never really works to basically just pick and choose, things that in the ecosystem kind of works. Some of them work spectacularly, some of them kind of works, and pierce them together. So your job is you're the best at your job when you write the least amount of code possible, when you own the least amount of your pipeline possible. And that is made possible by people and by companies that have been slowly colonized this new ecosystem of MLOps, right? And here are just some examples. We're going to see some of them in detail, but just to give you a flavor. So on serving and kind of exposing your model, you can think of some PaaS offering from AWS. Data warehouse, of course, Snowflake is basically the choice. For data transformation and data quality, you have these smaller tools. We're gonna see them, DBT and Great Expectation. AutoML is a hot field. I'm mentioning here Ludwig from my friend Piero, but there's other alternatives. For visualization, Preset is a hosted version of Superset, the Apache project started by Airbnb. For ML, there's Metaflow. We're going to discuss about that later. And for orchestration, there's all sorts of tools. Our previous startup was working on Airflow, which you probably know. We now have slight preferences for Prefect for some reasons, but it's like in the great scheme of things, details. The point is, by knowing how you combine this data and by knowing exactly what your company does and by knowing how to transform raw data into business outcome, you really don't have to do much anymore. Of course, don't tell to your boss or you're gonna get fired. But between us, we can actually be reasonably happy with the fact that we have way less work to do than it was to be the case. So 3 principles for data stack for reasonable companies. And everything we're going to say and do, or everything we say and do in real life, kind of is a corollary, like is a natural consequence of embracing these 3 principles. The first one is data is king. Everybody says that, but very few people understand that. So the marginal gain for you is always in better data, not in better models. Let's go back to what we said before. Most of modeling problems has been figured out by way smarter people in way bigger company. Okay. What your gain is to understand your data better than anybody else and to make sure that the data quality is what it should be. The corollary of this is that if you're really new to this game, the investment you should make is in data engineers way before people doing ML. Like people that understand data pipelines are way more important than people understand models, which they turns to be important, but after a while. The second principle is you should just focus on what you do. And buy everything else. As we saw in the previous slides, and we're going to see for the next 30 minutes, there's no shortage of solution for your problems. If you're a reasonable sized company, all your problem has basically been solved one way or another, or the vast majority of them has been solved by one or another, by people whose entire job is solving those problems. So you shouldn't really spend the time of precious resources like engineers to rebuild what somebody else built better than you would ever do. So less is really more. So don't write code that others work better, and don't maintain any infrastructure, because maintaining infrastructure is the job of somebody else. And unless you're an infrastructure company, unless you're building Snowflake, which you probably aren't if you're listening to this talk, okay? Unless you're building Snowflake, infrastructure is not a competitive advantage. Nobody's gonna buy your startup because you have Fargate endpoint or Kubernetes or whatever. Nobody cares, okay? So if your startup, let's say, is doing AI, it'll focus on AI and buy everything else. Okay, there's really no reason to spend time on something that doesn't contribute to the company. And finally, a bit more controversially, probably, distributed computing is the root of all evil. Like distributed computer should be avoided at all costs at a reasonable size company. And that comes from a guy that built a company on Spark and sold it. So Spark and tools like that were like very, has played a big role in the big data revolution and all sorts of things. But at the end of the day, there are better solutions today. There are better solutions today for several perspectives. Spark is slow. First of all, it's very hard to maintain, and it forces all sorts of non-natural patterns on people. Like if I hire somebody with a master's degree that knows, I don't know, Python at a decent level, that doesn't because of executing stuff in a distributed way. And I also don't want to spend his time learning that if there's another way. Thanks God, and mostly thanks to Snowflake, there is another way. At terabyte scale, there's really no reason for you to do distributed computing in basically 99% of cases, as the distributed nature of your big data is kind of hidden from you behind Snowflake. So let's say you have Snowflake and now you have a SQL query, and the SQL query, of course, is distributed, but you don't really know that because you just execute a SQL query. And then you can, once all the data is already been prepared for you, the data that actually leaves Snowflake and goes into your laptop or your container or in Metaflow, whatever you want, is actually very manageable. And that's come from a company like that have hundreds of clients around the world. And there's really no need for distributed computing much. Funny thing, a company is much bigger than us, Netflix, you probably know that, is actually already it's been following this divide for a while. Like Netflix put a lot of investment in making sure that even at Netflix scale, the type of data you work with every day is data that can sit comfortably in your laptop or in a reasonable container on the cloud. So the people that we hire, we can have them doing their best job without worrying about this stupid thing of distributed computing. So putting all together, this is what it looks like for a reasonable company to have almost completely PaaS, like completely hosted flow, when you don't really have to deploy any server to run, data pipeline at terabyte scale. Literally, you don't really need any person if you want to use this tool to actually spin up any machine for you or to maintain every infrastructure. And you can just pay all these companies, or like in case of Metaflow, you can use these companies to deploy infrastructure somewhere else. Metaflow deploys in AWS, which will deploy it for you and run it for you. This is not the only possibility. So this is like a kind of like a cookie cutter, like a template. But it kind of summarizes what are the most common use cases, at least in our experience, with the tool that we choose for the job. So going from left to right, we have your app. Let's say you're building an e-commerce and your e-commerce is producing data. Those data gets into Snowflake in what is called an append-only table. It's a table that just stores the data as raw as possible as it actually came in. And then you have an orchestrator, let's say Prefect, let's say Airflow, let's say Dagster, let's say whatever you want. And then the first thing that you're going to do is that you're going to use dbt. We're going to see that. You're going to use dbt to build from the raw data a sequence of tables that progressively build an aggregate feature for people to use. We're going to use feature. Well, BI people are going to use feature to produce visualization for the business. Awesome. Like machine learning people, data quality people will use these tables to validate that some assumption about the data hold. And then finally, machine learning people, top right, are going to take the result of this process and I'm going to build an ML pipeline. That is, I'm going to take this aggregate feature or pre-prepared feature, are going to do whatever wrangling magic they need to do to feed them to, let's say, a TensorFlow model. I'm going to train TensorFlow. I'm going to store the artifacts on S3, and then they're going to tell Sagemaker to deploy it for them. Okay, and in all this process, nobody has had to deploy any server. Okay, nobody has to do anything that it's related to infrastructure. Infrastructure is completely abstracted away from you. So this is the pitch, the high-level programmatic thing. But then the question is like, does it really work? Like does it even work? And so we can take an example on a real data set that has been released a couple of years ago. It's called the Cod Camp Gitter dataset, which is basically a list of messages that has been done on Gitter. It's like say Slack or whatever you use. Like it's just a chat basically. It's the dump of the chat of these people that were doing a bootcamp in a couple of years ago. And of course, they all agree on releasing publicly their data, and so their data now is a Kaggle competition. Everybody can download that. And so, what does the data look like? The data looks like, if you think of having this as a real use cases, the data look like a list of messages. Let's say from in this case, Rashid is like how is it to termino task at somebody else? So it's a list of messages that have a author. Of course, the author has, let's say, an image, and then the message is a text, and some message may or may not contain in this case, mentions, right? So what happens here, yes, is that the mention, maps to another user, of course, and then the message is, has some meta properties, like where was the channel where the message was sent, what is the timestamp, what is the what is the avatar of the user, how do we display the user, and so on and so forth. And you just get this long list. It's basically this, I don't remember if it's a CSV or a JSON, honestly, but it's kind of this long list of, raw data that is just dumped for you. And then what you do is that you dump it in Snowflake, like pretending for the sake of the example that this is the real data set you need to work on, and then you start working on that. And then once you have that, I don't know, maybe you want to build a recommendation model or whatever you want to build, and the recommendation model is a model that giving a person like Rasheen is going to recommend a user to follow or a user to to reach out to for whatever problem. So the phase one, and I think I need to unshare and share it again. Let me see. I think I should do this and then this. Tab. Can you see DBT? Hopefully you can see DBT.
Yes.
Okay, cool. So the first thing we're gonna do is that we need to go from what is the raw data. Let's imagine this raw record of JSON that we receive, and then we need to build our tables in a way that actually makes sense. And the way in which we're gonna do that by using DBT as a DBT functionality, which implicitly define a DAG, that is a graph of dependency. Why that concept is important? Because it's important for several reasons, and we're gonna just talk about one example here, but you can kind of hopefully see how that generalized to many more. We saw that this dataset has the concept of a user. Okay, a user can be either a user that is sending a message, like Rasheen in our example. So Rasheen was sending a message, so that user is gonna be found in the sender column of the raw messages. And then users can also be mentioned. Remember @penguin, remember the message that we saw an example? And these two sets, the union of these two sets is actually the entire user base of Gitter. Okay. Importantly, like some user may send messages but never be nominated, okay? And vice versa. Some user may be mentioned by other user but never be senders. So the only way in which, let's say we're building a recommender system, so we need to come up with at least a list of all the people that have been interacted with in this Gitter, and there's no way for us to do that directly in the data. And so one option will be, well, I'm gonna parse all the data. I'm gonna have like a Python script, I don't know, in a Luigi pipeline or something like that. I'm gonna get all the data and I'm gonna do this, this thing by myself. That's one option, of course, and that's that's pros and cons. The way in which we propose to do this is by using DBT. DBT is a SQL-based transformation tool, so it has nothing to do with where the data is. The data is in Snowflake for us, okay? But DBT acts upon that with this nice SQL interface that you see here, and kind of lets you define repeatable, versioned, stateless transformation that goes from raw data, what you ingest, to the actual table that you need. So if we go into a table here called all users, hopefully you see that. You see that DBT, this is just SQL, you probably can read it. But what you see here is that, I'm gonna highlight this. There are some references here, okay, in the from statement of this SQL. Like, don't really care about the SQL like that much. But this idea is that this table, which is called all user, so it's the table containing every user in this chat, is built with two other tables, the sending user and the mention user. Remember what we said before. A user can be mentioned but never send, and a user can be sender but never be mentioned. And so if you do this through naming convention, you can totally see the mention user here. You can click here, and there's another SQL query. And if you want to do the sending user, you're going to go here, and you're going to see another query. I think we can also preview the data directly here. So we're now querying Snowflake to simulate this query. Okay. And what happens is that DBT is smart enough to know that if you want to build the all user table, you first need to build the table that this table depends on, right? So you first need to build this one. You first need to be, what is this one? The mention user, and so on and so forth. So what happens here is that you have smaller queries, because this query now can just, assume that another query is built. So you don't have like, gigantic SQL query statement of 500 lines. You have smaller, tested translation, And if you imagine this at scale, it's going to be something that a team is going to build, right? If you imagine this in a real company, what happens is there are some people that are like responsible to do data aggregation at a very coarse level, like for example, defining all user. But then there's going to be people that have built on top of that to, I don't know, build a dashboard of the most active user, okay? And by having everything in the same repo in a collaborative way, complete version, we can always kind of go back to understand who did what, and we can kind of build on the work of each other, which is very important. So this is also, from culture-wise, a more inclusive way of seeing the data as really an asset of the company and not just something that it's in this gigantic, trash bin where, always some data engineers can go and look at that. So this is a way also to enforce a natural, division of labor, as in, more low-level feature and more high-level feature, but also in a collaborative environment, as even the BI guy doesn't have to open Luigi and Python. The BI guy maybe just knows SQL, and he can just even try to understand what the data engineering guy is doing. May or may not contribute to that directly, but it's still everything under one, let's say, under one roof. If I switch, I think I can do that in a better way. Can I switch my entire window? Maybe not three. Hopefully you can see me. Do you see GitHub? So do you see preset? Hopefully you see a dashboard.
Yeah.
So the point here is, once you have this this query, then you can go and build more complex thing. For example, what was this one? Yes. So now that I have the user table, okay, and I have a table that standardizes messages, what we can do, we can actually build something that give you the most active users, and so on and so forth. And the interesting thing is that most active users are a very high level feature that may be good on a dashboard, but may or may not be super interesting for data engineers to build. But thanks to the fact that somebody built a table called all users, when all users have already been normalized, there's no need for the dashboard person to understand the raw data. At some point, by having this transformation, we decouple the original problem of cleaning the data and normalizing the data from the problem of producing actual visualization. And all is done in, again, a version and replicable way. If you want, this is preset. You may be familiar with paid alternative to that. I don't know, Tableau is probably the most famous one. But the idea is that it's very easy once you have this, these queries and tables all prepared, to build in 2 clicks this somehow visualization that kind of tells you how things are going. And again, we're not maintaining any server. dbt Cloud, you pay dbt $50 a month, I think, to do this, but the real computation is run on Snowflake. So what happens is that dbt and Snowflake just exchange metadata, and this is the same. Like, there's a secret connection here between this and whatever Snowflake you have, and then preset cost, I don't know, $20 a month or something like that. But you don't have to maintain any of this. You just create a user, and then the user can just go on the dashboard. So all this functionality is basically provided without you having to run anything, because all of this depends on Snowflake, which you don't run by definition. So if you go back to our presentation, which you obviously see again, this is the DAG. This is the graph that is generated by dbt. If you see in the middle, there's most mentioned user, standardized messages. That depends on a previous table, which is the one that we discussed, which is all user, which depends in turn of mention user and sending user. And then, of course, there are even downstream tables that we didn't discuss. But the idea here is that if you follow this left to right, you can kind of see data going from very fine-grained details very close to the raw data you ingest, to very high level group counts and aggregation to the right. So the second phase is training a model, which is, well, now that all the data is there, hopefully, and we have the users, we have the counts, we have who talked to whom, we have time of days and so on and so forth, what you're going to do to train our data. And the way in which we're going to do that is with another DAG. So, because everything is a DAG at the end of the day. That is, with a series of steps in a system, in this case is Metaflow, and then that allows you to kind of run different part of the step in different environment. We can't talk much about Metaflow, but we kind of blogged about different times. So it's a super cool framework by Netflix. But The entire idea of Metaflow, which is the one that we want to discuss here, is the fact that Metaflow allows you to define your machine learning steps in a way that is somehow agnostic of when they run. So what really happens is that by giving you the possibility of spinning up job in AWS without you noticing that almost, you kind of get this feeling that you're developing locally. Again, no distributed computation. Like you run things from your laptop, from a small container, wherever you want. But then all the heavy lifting, let's say you need to train like a big neural network, can be offloaded to the cloud. So the machine learning developer now has the power to define for each logical step in what is building, what needs CPU, what needs GPU, what needs distributed training, what needs this, what needs that, okay? And that's very powerful because Metaflow under the hood just is gonna orchestrate, all the computation for you. So the only thing you care about is having requirement. Let's see, this step requires 4 GPUs, okay? And then Metaflow is gonna spin up, the AWS batch job that actually satisfies that requirement, and is gonna store and version everything for you, which is also very handy, as a lot of people use MLflow, weight and biases, a lot of other things to store artifacts. But if you use Metaflow, artifact storing is kind of given to you by default out of the box. And Metaflow is completely open source and free, as in, while DBT is open source, but you have to pay them if you want to use the hosted version, the one that I show. Metaflow for now exists only as a open source project, so you can kind of download it and use it in your AWS, and you don't pay them anything. You just pay AWS resources that you use. If you're interested in this, there's a blog post and some open code that actually tells you how to run, a Metaflow pipeline from zero to SageMaker endpoint, and feel free to go and check it out. So putting it all together, we have this, incredible. We have this pipeline that works at terabyte scale and works almost without, any DevOps or any attention. As all the things has been carefully selected to work, in their own cloud environment, to work with you being bothered, and to work in such a way that if tomorrow you have, let's say, twice as much data, most of these things will actually scale automatically by themselves. What may not scale is the model, but that's your job, right? There's still a tiny part of this thing that you have to do, otherwise you'll be completely useless. But that part is confined in a very specific part of this, which is what happens inside your Metaflow pipeline, which is the actual machine learning job. Everything else around you, which as you can see here, is actually the vast majority of pieces, okay, is kind of handled gracefully for you. So you don't really have to worry about that much. Gianmario, I'm going to ask you how much time we have left, because I wanted to have questions, and there's no need for us to finish the presentation. Yeah, but let me know how much.
We have a few questions accumulated, so we can either answer them now, or you can answer all of them at the end. But we have how much time you want. We don't have any.
Yeah, but yes, but I don't know. Is it sunny in Milan? I don't know. Maybe people have better things to do. But let me. So I'm just gonna skip very fast through this, because there's there's material on this on the web, so you don't need to listen to me talking about this. So the last thing we've been building, which is not to do with MLOps, but with the general problem of, end-to-end things that work in a reasonable size company, but there is a good company, is how you document your model. And there was a proposal by the Google guy, which was called Model Cards, for a few years ago, that didn't really took off for whatever reason. And we are kind of, making it cool again by building the version of Model Card for DAG, okay, for Metaflow, basically. Why is that important? Because unless you're Google, or unless you do this, I don't know, object recognition model API, like Azure, the atomic thing that you want to define is your machine learning DAG, not the model per se. As again, the model per se will tend to be less and less important in years anyway. And the most interesting thing is actually, how this model is surrounded by other pieces to do what they're supposed to do. Again, there's open source code that does this. You can look at my blog post. But this idea is that, I think there's a small video here. This idea is that once you build like a model with MLflow, you can kind of define a program that automatically produce the HTML page you see on the right here, which is a description of what the model does, what the accuracy was, where you find the training data, where you find the test data, which tests pass, which tests do not pass, and so on and so forth. And this is helpful because you have one documentation, it generates it automatically for you, so you don't have to remember to change a conference page because you changed the model. So you just run the model as you run the latest version, and then there's this HTML page that gets generated for you that tells you, well, this is what we know about this model, okay? And some of these parts are technical, I don't know, accuracy or artifacts. Some of these parts are actually qualitative. In a company like us, it's useful because sometimes there's a PM or, I don't know, a business person that wants to know what this functionality or model is about. And, if you add this type of cards, people can actually read them without bothering you, right? And of course, people can read conference, but again, if you work in a model, then you have to remember to update conference. While if your documentation is kind of automatically generated, you don't have to remember to do anything except, update your code, which is, again, your job anyway. Again, blah, 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 look it up. We actually have, did I? No, so I didn't include that because I'm stupid. We actually have an open project which is called Metaphorington prediction. I'm gonna put the link, I guess, in the chat or whatever, which is done in collaboration with the people that built Metaflow to take this dark card idea and making it part of the actual Metaflow ecosystem. The project is larger and is some sort of a cookie cutter project, like similar to what you just saw today with DBT and Gitter, but it's going to be completely open source, starting from the data that we released like a couple of months ago. So at the end of next point, what we're going to publish is an end-to-end data pipeline with a realistic load, like 30 million events. So, the famous terabyte scale, okay? That takes all these tools that we just discussed, DBT, Snowflake, Metaflow, and kind of release completely open source how you put all them together and you build your own predictions and so on and so forth. So we're actively investing as a company also in evangelizing the field and releasing code that is not just, towards the, just that, my GitHub, like this GitHub, which is clearly a weekend project, but build code that is built with realistic constraint, like realistic data loads, realistic tool, realistic cost, so that people can actually try and get a feel of, how this way of doing serverless MLOps work for them. Last thing, and then question, well, what's next? Well, first, what's going to happen to AI companies in the next couple of years? Well, it's still not clear because AI companies are really different from other companies for all sorts of reasons. What's certainly true is that thanks to the thriving ecosystem we're in, small team can accomplish incredible achievements if they know, which tool to use. But which means like, how does the ML team of the future look like? Like, how many engineers you have, how many data scientists, who's going to be your lead, and so on and so forth. The second, food for thought is if model deployment is solved, at least for like good companies, model monitoring is getting solved, as in there's a new wage of people that are trying to solve monitoring in production. Feature stores is the new kid in town. They're getting started. What is next? Like, what is the next big piece in this ecosystem to automate away and abstract away some complexity? I'm super happy to listen to your feedback or ideas about this. And finally, cards. How can we make them better? Oh yes, I mentioned it here. So we're working with a team from RecSys with build Metaflow to actually do that. If you want to be kept in the loop, please ping us, because we would like for people to start trying it out with the new cards and and tell us what they think about this feature. But please now ask me all the questions you want, and hopefully I'm gonna have some answers.
Wow, Jacopo, that was really inspiring. That was amazing. A lot of contents, a lot of ideas. Of course, that only probably applies. This applies mostly for companies on the cloud, I guess. Companies working on premise is going to be a little bit more complicated, I guess.
Yes, that's correct. Yeah, sorry, I didn't. Yes, reasonable on the cloud. Sorry, I kind of skipped that definition, but yes, reasonable companies are on the cloud.
For granted, yeah, I get it. Yeah, that's the way it should be, even for unreasonable companies generally. But yeah, let's not go into that discussion. We have a few questions. Shall I read them for you?
Yeah, because I don't have you. Yeah, please do. Yes, yes.
Okay. So I also ask a few of those.
Sure, of course.
So let's start in a chronological order. So at the beginning, you say that you don't need Spark SQL. You can do everything in Snowflake. And I understand for SQL queries, but what about programmatic data processing, where in Spark you would use any programming language, either Scala or Python or Java, to leverage the RTD API to do this big scale computation programmatically? Can you do that in Spark, in Snowflake?
So Snowflake allows you to define some function first, but sure. But the truth of the matter is that depends on your sophistication as a data company. But if your data ingestion, like if you control data ingestion, as in you have a protocol for people sending you data, like, I don't know, like for example, this is our case. The high level transformation that you need to do for feature to be usable tends to be kind of confined to good SQL query, some regular expression, and a bunch of JSON modification. Snowflake is very good with JSON, like with JSON manipulation. So that, in our experience of a reasonable company, covers 99% of the data transformation that you need to do. If, of course, you work with super unstructured data, you just work with long documents of like 10 pages that you, I don't know, scrape from PDF or something like that, then may be a different thing. Again, my point is like things should be avoided at all costs if possible. If not possible, of course not. But we built an entire company based on that. But there was no Snowflake at the time. But then we started moving at the end of Tooso from Sparse SQL to Athena, okay? Because again, with this serverless kind of idea that I don't have to maintain stuff because it's stupid. But then Athena is very limited in SQL capabilities, and there's a limit of scale that it gets reached pretty quickly.
Yeah.
But Snowflake for us superseded Spark SQL, Athena, Redshift, everything, because it's better at SQL than anything that it scales better, and it gives you this pass feeling, right? You don't have to set anything. The only thing you can tell Snowflake is like t-shirts, XL, medium, L. That's the only thing you can do. By design, if you never read the Snowflake paper, I strongly suggest people to go back and read the original paper by Snowflake, which is really good in how they design this idea of you don't have to worry about stuff. So Spark SQL, I'm sure that for many use cases, is still super necessary, but in many others, is not. That's my point. Like, don't take it for granted anymore.
Yeah, no, I'm familiar with Snowflake and all the benefits. It's great technology, probably the best for SQL. My question was more on the things you can do with functional programming that are hard to code in SQL or hard to test in SQL. But I get your answer. If you do in SQL, then yeah, Snowflake. Yeah, totally. Yeah. Thank you, Jacopo. Let's move to the second one, which is you showed a few tables built on top of Snowflake using dbt. And the question is, can you do the same directly in Snowflake? Why do you need dbt on top of it?
So dbt, you can do directly in Snowflake, of course. You can imagine doing this manually. Let's say you have the mention user table and the sending user table, and then you can have a SQL script, or I don't know, a Python script that calls a SQL script, and one is called 001, and the one is called 002, and one is called 003, and you execute that in step, or you just kind of bullet like encode that in a thing. The problem with that is that first, your code doesn't really reflect directly any dependencies between this thing. You don't get the testing. We didn't get into that, but dbt also can test single like part of that. So you can define for each of these query a single test that needs to be run to make sure that things actually work. And then you have this, I think, nice open source abstraction that allows you to kind of decouple the database. I mean, I love Snowflake. I don't think I'm going to change it, but you can kind of use dbt with all sorts of other tools anyway. So you just don't go that directly into Snowflake. But the main point is that dbt is a more explicit thing of this DAG of this pipeline, and I think that's very powerful when you try to move from a 2-person team, 3-person team to a 20-people team. And now again, everybody needs to build on top of the work of each other, and we don't want to step on each other's toes. And I think dbt gives this nice separation and replayability that is just a better use case.
Sure. Yeah. especially with the data mesh architectures, and you need to start to live with different teams producing data, and as you say. Okay, thank you for the explanation. Dorian asked if you need Snowflake to use dbt. And I think you kind of answered that because you say this is an abstraction. So probably
Yes.
work on other databases.
Like yes, exactly. So Snowflake is just the way. Snowflake is what runs the computation, right? Everything. So if you remember the diagram that I show you, right? There, like, what is the most important piece of that is Snowflake, right? Because it's the one that if you remove, everything else falls apart. The second most important thing is Metaflow, okay? Because Metaflow is hard to replicate nowadays. There are very few tools that do what Metaflow does, and not in the same, again, serverless kind of way. dbt can be somehow faked by different tools. I like dbt, and I think I suggest it, but there's a world in which you don't do that. And other tools which I like Prefect, can totally be replaced without changing anything by, let's say, if you like Airflow 2.0. Okay, so there are some of these things which are, I would say, more a matter of personal preferences, and there's some of the things which I think are generally kind of more unique in their category. And in this continuum, Snowflake is, on the unique side, and Great Expectation is on the not unique side. I still like it and I still use it, but I can totally see on world where people say, I'm not gonna use another tool for that. I'm just gonna use dbt test. Let's say you have dbt, you can do dbt test to do some of the things that Great Expectation does. We didn't talk about Great Expectation, but the point is, like, there's some overlapping here and there. But some of this overlapping is more crucial, and some of less is less. We mentioned weight and biases. Comet is another great tool. I like them both. MLflow is another great tool if you want to. Like, it's a matter of personal preferences at that point.
Cool. Let's follow up on the Metaflow thing. You say the Metaflow is not replaceable. It's kind of unique. But then Metaflow is working on top of SageMaker. And the question is, can you do everything that Metaflow is doing directly in AWS using the latest functionalities of the SageMaker platform? Namely, pipelines and all of those new features they released.
So I'm not familiar with the latest SageMaker pipeline. That's very new. What I take SageMaker to be, at least for us, is mostly like a pasta serving option, as in, I don't want to be bothered by serving and replicating endpoints at scale. So I'm just gonna get you the model, and you're gonna do whatever you want with it. We don't even use SageMaker for training. So SageMaker notebooks are cool, but that's a different thing. But mostly it's mostly a serving layer. Metaflow doesn't really, for now, it's not really a wrapper around SageMaker. A wrapper about basic AWS resources, typically AWS Batch, but now AWS Lambda as well. And kind of gives you this control of, like, everything is on my laptop, or feels like it's on my laptop. But then specific part of my code gets offloaded to the cloud in a way that I can control. And then resources are going to be spin up and down, depending on what I use, which I think for reasonable companies that still do ML, it's a good compromise. If that depends on your sophistication, that's true. Like, if you're happy with some pre-made stuff by SageMaker, probably you don't need Metaflow. But if you still have a huge component of, like, if ML is still a huge part of your value proposition, like it is for us, there's still ways in which I can just be happy with a pre-trained model. Even when we do research, right? When we do research, we can just go and use SageMaker to do that. And for example, Metaflow is very nice for us to parallelize hyperparameters. Like when we write a paper and we need to run benchmark or experiments, kind of Metaflow kind of automatically gives us this possibility of us running 100 models in parallel, and then use weight and biases to kind of like summarize that. So that has been working for us. So yes, if you're, it's irreplaceable for us. It was a super strong statement, yes. But I really suggest, if you don't want to use it, check it out, because it's a nice way of conceptualize the developer experience of a person working in ML. Like, it gets your life better. That's my point. Then it may be too much for you. I do understand that, but I think it's a nice thing.
Great, thank you, Jacopo. Actually, when I saw your previous talk, then I learned about Metaflow. I read the whole documentation, and it's really inspiring from a design pattern point of view. Is really good. I do think that SageMaker can be used more than model deployment, because they have released all of those how to do the training jobs, how to do all the pipelines, all those kind of things. I don't know if they work very well, because I haven't had enough time to actually experiment with that. But it's good to know that there is at least Metaflow that we know it works. So even if the SageMaker is not meeting expectations, we can always fall back to the lower AWS service like Batch or Lambda and orchestrate everything through this framework.
Yeah, you never really see AWS or Lambda, like Batch or Lambda in Metaflow. You just say GPU equals 8, and then Metaflow is going to figure out which AWS batch to run for you. So you don't really see any of the AWS. If I don't tell you that the AWS, it's just going to look like it's just going to be like a slow program because it has to go to the cloud. But if I don't tell you that, what step is executed locally and what step is executed remotely, there's no way for you to know, which is the beauty of it. Just this idea that, when you run computation, it doesn't really matter. What matters is your experience as you define your Python code.
Yeah, totally. Great. Let's see if we have anything else. The DAG cards. So you're working on this project for generating those automatic reports in a HTML format. And are they saved into the model registry? Namely, in this case, I guess weights and biases, and then you retrieve from weights and biases.
So you mean the
model cards?
The model cards themselves in this moment are just they run on my laptop because it was a weekend project. So that's what it is. But it's a weekend project that's open, so you can run it on your laptop as well. What we're building with the Metaflow team is a more structured way to define these model cards in such a way they will become part of Metaflow, okay? Which may mean, for example, you can render them like whenever you want, or as part of Prefect. Prefect allows you to render custom UI, so you can actually render them there, or you can save them in weight and bias if you want. We don't use weight and biases to store any artifacts because we use Metaflow for that. So we don't plan on doing that directly, but people could think of doing that. Now we're more in the testing phase of, we did this in a weekend and we thought it was cool, and I think it's helpful. How do we make this part of the general pipeline and collect feedback for people? So guys, if anybody of you really has a use cases for this, I'm really serious, like please reach out, because we want to know what people would do with it. For us, it was a way to not update Confluence, mostly, but because we're lazy people at the end of the day. But maybe you have even more interesting cases, please reach out to us so that we can take that into account while we build this first POC with that.
Awesome. Okay, thank you, Jacopo. I think there are no other questions on YouTube. So I think we can finish here. So let me thank again for the very insightful and inspiring talk. Rich of contents, rich of to-do task now for all of us. And we will publish the slides with all of the links, because we really want to follow up on the resources you linked in one of the last slides. So for everybody watching to the meetup, give us a couple of days and you will find the slides on our SlideShare channel, and you can follow up.
Thanks so much for the invitation. Thanks, guys, for being here. If you have specific questions on, reach out to me. It's very easy to find me on LinkedIn or whatever, and just drop me a message. And thanks again. And I'm gonna add to the slide maybe a link to this new open source repo we're putting together with all these tools working end to end. So that all the things that you saw today on my DBT and my preset can be replicated on your laptop or on your cloud, so that you can give it a try in first person and see if it what it does for you.
Awesome. Thank you very much. Have a good night, everybody.
Grazie. Ciao.
Ciao a tutti.